So here we go. We are factoring special products, and the one that we're going to focus on is the first one, this a plus b and a minus b. So let's remember how to do that. If you've got two binomials, what do you do to get the answer?
Multiply.
You multiply them by being fair. Remember, you have to do a times a, that would be a squared, and a times negative b would be negative ab. And then you have to be fair with the b. So b times a is ab, and b times negative b is negative b squared. And then as we look at these two, they cancel. So we're left with a squared minus b squared. And this is called the difference of squares. The reason it's called the difference of squares is two reasons. One is that we have a subtraction, which means difference. Okay? We also have two terms. So we have two terms with subtraction. That's important. Two terms with subtraction. We also have those terms, and they are perfect squares. Let's understand what perfect squares are. Okay? A squared, I'm telling you, is a perfect square. What multiplies to a squared? A times a. The a multiplied by itself is a squared. If I was to tell you that 9 was a perfect square, what two numbers make up 9? 3 and 3. So it's the same. It's 3 multiplied by itself gives you 9. That 9 is a perfect square. So you tell me one.
106.
100, because 10 times 10 makes it perfect. Okay, I heard 16 first, and then we'll do 144. What makes 16 perfect? 4 times 4. I also heard 144. What makes 144 perfect? 12 times 12. Let's do one more. What about x to the fourth? What makes x to the fourth perfect? X squared times x squared. It's one thing multiplied by itself to give us that number. These are called perfect squares. Okay, so you need to kind of start recognizing that these are perfect squares. If they are perfect squares, your life is much easier. Okay, because rooftop is not necessary. And so it makes it to where you don't have as much work to do. All right? Now remember, just like on Friday, the very first step that we need to do is figure out if there is a greatest common factor. So is there a greatest common factor here? Number one, greatest common factor. Is there a greatest common factor here?
No.
No, there's not a greatest common factor. So we move on to the next step. Are there two terms or three terms? There are three terms. Okay, so because there are two terms, the next thing we do is we say, now if there were three terms, then we would try to do the rooftop, right? Oh, I'm sorry, there are two terms. Thanks, sorry. My brain was working faster than what the paper was. All right, so it does have two terms. And if there were three terms, then you would use rooftop like we did on Friday, okay? But this one has two terms, and so we can't do the rooftop. So what we have to do now is we have to ask ourselves the question, if there are two terms, is it the difference of squares? The difference of squares. And I'm going to put a little square on there. Is it the difference of squares? Difference of squares. All right, so let's check all the qualities of this binomial and see if it is the difference of squares. Is x squared perfect?
Yeah.
What makes it perfect? X times x. 49, is that perfect? Is it negative 7 times negative 7 or negative 7 times positive 7? And it's the negative 7 times the positive 7 that makes the negative 49. So does it have a difference then? Yes. That difference, remember, is what makes that middle term go away. Since they are the difference of squares, it makes that middle term go away. So now all we have to do is write our two binomials, our factors for this one. We put our x's at the beginning, and we do 1 minus 7, and we do 1 plus 7. Because remember, if you were to check it, x times x would give you x squared. X times 7 would give you 7x. Negative 7 times x would give you negative 7x, and those two terms would cancel out. And then negative 7 times positive 7 is your negative 49. Do you see how that works? Okay. So the difference of squares gives you that kind of an answer. So let's move on to letter B. Number 1, is there a greatest common factor? No. And so now we ask ourselves, does it have 2 terms or 3 terms? It has 2 terms. Remember, if it had 3 terms, we would try to rooftop it. But it has 2 terms, so now we ask ourselves, is this the difference of squares? Okay, so what is 16 perfect? 16y squared?
Yes.
Yes. What makes 16y squared perfect? 4y times 4y. Is 81z squared perfect?
Yes.
Yes. And is there a minus there? Yes. So then that means that we will have what? Negative 9z and positive 9z. So because it fits the qualifications of it being the difference of squares, we can go ahead and put these things into our answer. So we will do 4y and 4y. One is a negative 9z and the other is a positive 9z. Remember, it's exactly the same except for that minus and the plus make that middle term go away. Questions? All right, let's go ahead and look at letter C. Letter C, first of all, we have to find out, is there a greatest common factor? Okay, yes. Since there is one, we go ahead and take that 3b out of there. And what is 3b times what will give you 3b to the third?
B squared.
B squared. 3b times what will give you 27b? So plus 9. All right, remember, once you take out the greatest common factor, what's left in the parentheses, you have to see if you can factor that. So, are there 2 terms or 3 terms? There are 2 terms. If there were 3 terms, remember, you would do rooftop. But there are 2. So now you ask yourself, is this the difference of squares? Is this the difference of squares? The b can go, right? And the 9 can go, but is this a minus?
Does it have to be a minus?
So that when you multiply this one right here and this one right here, the middle term will go away. That's why it has to be a minus. You can't factor in addition. Okay, so because you can't factor in addition, let's write that down. You can't factor in addition of 2 squares. Can't factor addition of 2 squares. It's not prime. Why is it not prime? Because you have a greatest common factor. Now, if you were to do it, and let's say that to begin with, this one had a plus in it, even though these are perfect squares, this one would have been considered prime because you didn't have the difference there. Okay, so if it had said 16y squared plus 81z squared, even though these are both perfect, this is not a minus, and so this one would have been prime because there's no greatest common factor to factor out. You might want to write that one down. This is not a minus. Because it's not a minus, this one would be prime. Okay, right here. If all I did was change this and put a plus there, so the pluses and minuses are kind of important here. So because there is a plus here, It is prime because it has to be the difference of the perfect squares. Yes, these are perfect squares, but this is not a difference. Okay? Let's look at letter D. Letter D, we have y to the fourth minus 625. First thing, does it have a greatest common factor? No. So then we move on. Does it have 2 terms or 3 terms? 2 terms. And so we ask ourselves, is this the difference of squares? Is y to the fourth perfect?
Yes.
Yes. What makes it perfect?
Y squared.
Y squared and y squared. Okay. Is 625 perfect?
No.
Nobody remembers what that one is? Try square rooting 625.
It's 25.
It's 25, right? So one of them has to be a positive and the other one has to be a negative for it to cancel out the middle terms. So then this would be y squared plus 25 and y squared minus 25, but we're not finished. Because this one ends up with an answer that has a squared, we need to see if it can factor any farther, okay? So this y squared plus 25, it has 2 terms. Is it the difference of squares?
No. Yes.
It has perfect squares. Is it a difference? No. Because it's an addition, we can't do that one. So this one just comes down y squared plus 25, okay? But look at this one. Is this the difference of 2 squares?
Yes.
Yes. So y squared would break down to y times y, and negative 25 would break down to negative 5 and positive 5. 25 is perfect because of 5 times 5. One needs to be negative, one needs to be positive. So then this would be y plus 5 and y minus 5, and we're done. Why didn't I do it? Because it's an addition. Remember, it has to be the difference of squares. It has to be a minus there. Okay? All right, let's take a look at the back. That's the only one that you're going to have to memorize. If you got 2 terms, you have to remember if it's the difference of squares or not. Okay? That's the only one. Now on the back, we have trinomials again. We've got 3 terms. Okay? And so really, there is a shortcut to this, but I'm not going to teach it to you today. I don't think that y'all are quite ready for that yet. And so really what you're going to do is the exact same steps as what we did on Friday. Number 1, is there a greatest common factor? Yes or no?
No.
No. So number 2, the next thing you do is ask yourself, are there 2 terms or 3 terms? There are 3 terms this time, and so you're going to do rooftop. Okay? So if we do rooftop, this gives us 16x squared and negative 8x. So we do our multiplying, 1x times 16x, 2x times 8x, and 4x times 4x. And we add. This is just like what we did on Thursday and Friday. So which one of those is going to help us get the negative 8? And what do we have to do to make it a negative 8? Make them both negative. So then that negative 8x turns into 2 negative 4x's. So x squared minus 4x plus 16. And so remember, the next step from here would be to break these down into 2 sets of parentheses.
Someone's hungry.
All right, so then what is the greatest common factor of these?
X.
Just an x. So x times what gives me x squared? X. X times what gives me negative 4x? Negative 4. Because this is negative, we pull a negative in front here. And what's the greatest common factor there? 4. So negative 4 times x gives you negative 4x. And negative 4 times negative 4 gives you positive 16. And remember, these have to be the same in the parentheses. So you end up with x minus 4 and x minus 4. What you'll notice is that those are, or what you should notice is that those are the exact same. All right, now I'm going to skip around a couple. On this one right here on the application part, remember, if it's giving you an area, it's asking for a length and a width. And because this one is a binomial, it's got two terms and there's not a greatest common factor, you're going to do the difference of squares on this one. And you'll end up with two sets of parentheses. So you're going to have to factor on this one when it's asking you for the length and the width. Okay? And so I'm not going to continue on that. I just wanted you to understand that if it gives you a word problem like that and it's giving you the area, that you need to factor it into your two binomials. Okay? And if you wanted to make sure that you understood what to do on that one, it's AB minus 8C and AB plus 8C. Excuse me, C squared. Because the A squared B squared is perfect and the 64C to the fourth is perfect. All right, so if you would go ahead.